Hello, I'm Mr. Heck. I am the materials lab teacher here at Fleetwood Area High School. We're going to talk about the metalworking course, Metals 1. Metals 1 starts off with research. So I have the students looking at some YouTubes, watching some processes that we're going to be doing in class. It's always good to see multiple people with knowledge doing the same process, because sometimes there are slight differences in what they're doing, and that can be explained, or it can just be a preference type of thing. So to see those two things helps people to make a connection between the two processes and understand the reasons better for doing certain things certain ways. We have the applications of those processes. Where would we use those? Where would we use those in industry or in careers, or where would we use those in our own homes for doing things? Such as which process would be used for putting two pieces of steel together, or two pieces of copper together. So the main thing in doing this, and this is after we've gone through the process of looking at applications and so forth, is that the students are going to develop a level of confidence with using metal as a material here. Enough so that if they have the need to be able to manipulate, and that could mean shaping or bonding or finishing metal, that they have a background in it, so that in the future when they go to access a YouTube that would be talking about it, some of this information, some of the hands-on experience they had prior is going to be able to come back to them. So the course begins with a propane cylinder torch, where we take two pieces of steel and we go ahead and we solder the two of those together in a T-type solder, trying to maintain a 90-degree angle between the vertical and horizontal piece of the T. That's something that is an application to residential pipes, water pipes in a house. We have copper pipes in a house that gets soldered together. A lot of times we're using PEX now, but 95+% of homes are copper pipes, and it's a good thing to have knowledge of being able to do. If you're looking to add an extra faucet or an extra spigot to the outside of your house, or put a new bathroom in, it's something that's going to be required to be able to do. Okay. After working with the soldering, we work with a material that's pretty similar to solder, with a little bit beefed up heat, where we use oxygen acetylene tank, and we braze. So in this situation, we're making what's essentially a set screw. It's a 1/4-20 bolt that we are brazing onto a 3/8 by 3/8 square stock, and we're using a hacksaw to cut out a notch that the bolt can sit into, and keeping that at a square 90-degree angle there. That gets put together. We round the ends using at first a hacksaw and then also a belt sander to get the ends right, making sure it's square this way as well. We make a flat stock, a 1/8 thick by 1 inch wide by 3 inch long flat stock here, that we put two holes in. The middle hole is larger, and it has a nut that goes over top of it, which accepts that 1/4-20 bolt that goes into it. Next to that is a hole that's drilled using our tap and die chart to find out what size would be the right pre-drill for a 1/4-20 threading. We pre-drill that, and we go ahead and we tap that to see that we have threads in that as well. So it shows two different variations of how to do this set screw, two different ways of making the threading here. One where they're already made on the nut, and we're just going ahead and putting that into the flat stock, and the other one where you're actually cutting the threads yourself. Okay. Next is we have a project that is a marking gauge. So on the marking gauge, we are introducing students to some of the machinery that they likely will not see again. So this is a small portion of the project that they're going to be using a vertical mill and a metal lathe for. And I don't spend a lot of time with those two machines, even though they are investments for the district here, because I don't think students are going to have the availability of these to them in the future. Certainly. I have students that, despite the fact that this metal shop class is not intended to put people out into industry, I have every class a student or two who something clicks for them and they feel like this is a route that they would like to go. I have numerous students, more than two, down in the trooper area outside of Philadelphia, working as machinist toolmakers presently, and loving it. I actually ran into both of them, or two of them recently. But we have the vertical mill that we'd be using for part of that process. And we also have, over the side here, we have a metal lathe, and there's another one to the other side there as well, another metal lathe for students to work with. So that's a very small part of the course here, and the reason being is because I don't guarantee that those students are going to see those again, but I think exposure to those, just to see what they are and how they run, is valuable. I also introduce students to casting. So both these pieces here were cast in the shop here. I don't do casting for every student. I do demonstrate it to every student, but the cost of materials for the aluminum and the time that it takes per student to be able to do that prohibits us from really doing more of that. So we also work with sheet metal. So students make a sheet metal box, working off of plans for this. Everything has plans to some degree, but this has some very particular plans for the sheet metal box. There's a piano hinge in the back here. But each student will make the sheet metal box, and then we talk about how we're going to be putting finish on that. Students get instruction in spray painting it with primer first, and then with the overcoat enamel, despite the fact that so many paints now claim to be a primer and paint in one. Students that finish early enough can make a copper mug. This is a copper mug that was made in here, soldering using a lead-free solder, the same type that we would see in our households there, to solder any kind of potable water type solder joints. But this is one that was done in here, and it's not every student that's going to get to do that, because in the second semester we generally have the opportunity to go to a scrapyard. It's a metal scrapyard, so it's metal that is not in the form of like an old furnace that you're going to take pieces off of. It's, you can go out there and buy square stock. You can cut it to the length that you want and pay for it by the weight. So it's similar to the metal that you would see at Lowe's or at Weaver's that comes in certain lengths. This stuff comes in 20-foot lengths. You cut what you want from that. A lot of the stuff does have rust on it, or just surface rust that we have to get rid of, eliminate when we get back into the classroom here. But students then can make a project that they want to make. So if there was one aspect of what we were doing in here that they liked a lot, or one aspect that they didn't really get to try as much as they would have liked to, like many students like to do the welding, then sometimes they'll go back and they'll say, I want to choose a project that has a little bit more welding in it because I want to try that out more than I did in the earlier part of the class. Here, a student made a sculpture. This is an owl sculpture. Sets like that. It's almost like a garden sculpture is what I would call it. But the student can challenge themselves or make things easier for themselves. This student did a challenging project where they welded up this spiraling table. You can see that it has these pentagons at the top and the bottom, and the legs are diagonal from corner to corner of the pentagon. It was a more challenging piece than some of the other ones, and he did that with the MIG welder and square stock from the scrapyard. So I want students to feel like they can handle what their project is, and they're the ones that decide on what their project is. In the very early portion of this, in the beginning when we're doing the research and looking up YouTubes and everything like that, I'm asking students to find some examples of metalworking projects that they have interest in or they think are cool, you know, just to gain an idea of which direction they would head when they go to look for a project. So somewhere in the middle of the semester, the students and I will talk about what they want to do, and we'll get the materials to be able to do that. Okay? But again, the bottom line for the course is that when a student walks out of this class, my hope is that they feel confident enough that if they had to do something involving metal as a material, that they would know the resources of where to find out how to do it better, or how to see the process again, and then have the comfortability to really try that process in a safe manner. Okay? Thank you.